Right, we are in quadratic patterns still and starting today with sequences and series. The last question in that exercise said, a sequence with a general term a squared plus bn plus c. What is that? Quadratic. A quadratic sequence is given. The first term is 5. The value of the first difference of the sequence is 6. I don't completely agree with their wording there, but I'll explain now why I say that. And the second difference of the sequence is 4, and is also constant. Determine then the first term, etc. So let's say again, the first term is 5. So we write 5. The next one is not 6. The first difference is 6, and this is where I have a problem. Because these first differences will differ. And the second difference will be the same. But the first difference, I would have said, I don't know how exactly I would have said it, but the first difference, first difference, something like that, that's horrible English anyway. But the first difference in the first difference is the first one is 6. So then that one is 6. So all of them are not 6. And then they say that the constant second difference is 4. And then they say, find the first 3 terms and find the nth term, which is our basic always thing that we bargain on for 4 marks in an exam. So how are we going to approach the sum, do you think?
5 plus 6. Then you find the second.
Okay, we're working backwards, do you see it?
Yes.
And there's other ways of doing it. If you wanted to, you could have said, well, I don't know what they are, but let's call them x and y. Worst case scenario. Will work, but it's worse. If you wanted to do that and say it's x and y. And then this would be x minus 5 that's equal to 6, and we can go and work out the sums like that. It's not bad, but the easiest way was work backwards. So if this has to be 4, then this has to be 10. If this is 6, then this is
11.
If this is 10, then that must be
21.
And then we can carry on because we know this stays 4 because it's a quadratic sequence. So this will be 14,
35.
and 35. So the first 3 terms are the first 3 terms. What did they say? The next 3 terms. First 3. So we only needed 5, 11, 21. So if you write 35,
It's fine. But
it's okay if you put extra, but just don't put 2 if they're asking for 3. Then let's finish up. So we would have 2a equal to 4 for our first step. So a equals 2. Second step is where 3a plus b equals 6. And our a value was 2. So the value of b is 0. Can b be 0?
Yes.
No problem. Number 3 is where a plus b plus c must equal 5. So this is the routine work. That's why we call this level 1. So we're in routine now. So then that would mean a was 2, b was 0, and c is equal to
3.
So that our general term,
2n squared plus 3.
2n squared plus 3. Now quickly tell me, b can be 0. What does that imply? Remember, this is a parabola. When we sketch this thing for tn even, and this is tn and this is n, we can have something similar like yesterday. Well, let's make it different. Let's make it something like this. There's a parabola. But this wouldn't make any sense because n cannot be negative. In actual fact, n can only be 1 and 2 and 3 and 4. It can't be anything in between as well, right? But if b was 0, it meant that your parabola has to turn on the y-axis. That's the fact. If c is 0, can c be 0? It could be 0, and then what would that mean? C is the y-intercept. So that would go directly there through the origin. Can A be 0?
No.
Why not?
Then it's a straight line.
Exactly. Perfect. If A was 0, then this is Bn plus C, which is a straight line. So if they're giving you a quadratic sequence, A cannot be 0. If you got 0, you made a mistake somewhere along the line. It's just a double check. So then we will carry on with the sequences and series. Okay. It's on pause? All right, so let us get into sequences and series, because everybody's going to say grade 12s are now busy with sequences and series, and what is that? It's still number patterns. When you get into a test and I say get the general term, get the next term, whatever the questions may be, you see it's number patterns, then now your list is going to go longer. Because you would always check first if it was a linear number pattern. If it was, then you're done and you go on with your sum. If it was quadratic, something else to do like we've just been completing. But then you also get geometric. Now where's arithmetic? Now I'm saying here that arithmetic is actually the old linear. It's getting a new name because there's a lot of new things coming into it. Can you still use old things if you were able to? Yes, but you cannot sit there and think, man, I like this one, I'm going to stick to this one. Because you're going to need this one for other things. Alright, so this will still work when it's appropriate, but you're going to need this one in specific cases. So now get into the habit of getting the general term of an arithmetic pattern by doing this formula. Now I've got to explain that first of all. A in this pattern is unknown to you, is not this A. It's not this A. This A used to be the difference, right? Whatever the difference was, you'd fill it in, you'd find your B, etc. But for this one, A is term 1. So if I give you the example, your A would always be your first term. So A is equal to 21. But okay, I'm running ahead of myself. D is now something different. And D stands in English for the difference. It's the first difference. Because it's not something new, it's still the linear pattern. There is also a constant first difference. So D stands for difference. So let's do the sum. This particular sum, number 4, of exercise 1.26. Find me the general term. So first of all, and I gave you one that's got a little bit oomph, because it's not just 2, 4, 6 or whatever. You've got to go determine if this is arithmetic. I think you're thinking yes, because this is my example, right? So if I look at the first differences, what would they be? Don't look at it. If you start looking and wondering, take the calculator. Because the difference is the second term minus the first term. And that has to be the same as the third term minus the second term. Now we're starting to be very technical in our way of writing. You've always been doing it. Saying that minus that, and what was that? Negative 3 quarters. And 9.5 minus 20.25, guys, you've got a calculator. Please use it. There's also negative 3 quarters. So that is your constant difference. So your difference is negative 3 quarters. Do you need to always write all of this? No. Well, for a start, now it might be a good thing to always keep it in mind. It's always the second minus the first. And forever, the 10th minus the 9th, the 100th minus the 99th will also still be negative 3 quarters. But your A value was
21.
21 because it's the first term. Now they're asking me for the general term because there is a new formula which says A plus n minus 1 D. Now I gave you the formula sheet that is at the back of every single question paper you're going to be doing this year. Formula sheet. So learn to love it. Look on the formula sheet and see if you can find that. Now I can't find my own. But on the formula sheet, it's about the third, it is the third line. It'll start off with Tn equal to this one. You find it? You've got to learn to love that information sheet. Know that it's there for you. Know when you're looking for something, oh, it's here. It's there. Okay, so that you can use it properly. effectively. So if you want the general term, then all you need to substitute is your A value of 21, n minus 1 in a bracket, because n is the general term, right? I'm not going to substitute n now. And then I'm going to substitute d with
Negative 3 over 4.
negative 3/4. Now guys, if you did this in the matric n exam, you're done. You don't have to even simplify. We are used to simplifying, but that is a general term. More often than not, the sum carries on and you would like to simplify. So you're going to simplify at some stage anyway. But there is actually full marks for the first one, just getting the general term, which is basically for knowing A and D and putting it into that formula and getting your answer. So it might be 2, it might be 3 marks. Generally it's 2 marks. There's your general term. The second question asked to find term number 35. So for term number 35, what are we going to do? Substitute the n with 35. So we substitute our n with 35. And punch it into your calculator and you get your answer of, please. Got an answer, please?
Yeah.
Okay, I was just checking this out. The negative, does it make sense?
No.
This thing is going
Backwards.
less and less. Sometimes it's going to get to negative. If you keep subtracting negative 3 over 4. Are you with me?
Yes, ma'am.
Okay. So at some stage you're going to get to 10 over, minus 9 over 2. And I'm done. For the next one, they're asking me which term will be equal to 10 and a half. Do you see the classic grade 8 and 9 style? Find term 35, then n is 35. But if I want to know which term is 10 and a half, you don't put 10 and a half into n. I know you would have known it's wrong because n can't be 10 and a half anyway, but say they say 10. Can't put it into n, it's which term. So what do we do?
Substitute
Into the formula, equal to minus up to 10 and a half. Now guys, that would be 1 mark, and your answer for knowing what n is would be the next. Because in the middle here, you can go crazy with your techniques. Everybody has their favorite techniques. There's lots of fractions here. Maybe you would like to do LCD, all sorts of stuff. It's up to you. Show me, don't show me, but don't make mistakes without writing the steps. Okay, so help me. If we had simplified it there, I would have had less to do now. Somehow, somewhere, we're going to simplify. We have 21 minus 3/4 of n plus 3/4 equal to 10 and a half. In general, when we're working with fractions, we like to say 10 and a half is 21 over 2, but it was not necessary because you're just going to do this with your calculator. Whether it's 21 over 2 or whether it's 10 and a half, it doesn't matter. Help me to do the sum. So I'm going to have minus 3/4 n equal to that minus 21 minus 3/4, and it gives me, please, (21 over 2 minus 21 minus 3/4).
45, negative 45 over 4.
Okay, this is now not yet n. When I get to n and my answer was negative 45 over 4, I knew something was not lacquer. N has to be positive and it's got to be a whole number. Right, so I can't do that. But what is the answer for n here?
50.
How do you get there?
I divided by 3 over 4.
Okay, so actually what you're doing is dividing by negative 3 over 4, which will give you then positive 15. All sorts of stuff you could have done. Leave away the 4, because you can do that. Then you've got 3n and you've got 45, divide by, take 3 steps, take 5, but I'm just going to give you a mark for the answer. Are you with that one? Okay. As to get more difficult very quickly, the next question says, number 6 on page 8, says the fourth term of an arithmetic sequence is 36. So we tend to want to do what we did at the previous sum. We've got 1, 2, 3 terms, and the fourth term is 36. And the 11th term is 99. No. So we're going to add x, y, z. We're going to run out of alphabet letters to put them all in there. Are you with me here? Okay. The fourth term is 36. So I would like to write the following. Fourth term is 36. Are you happy on that?
Yes, ma'am.
Okay. Then they also say that the 11th term is equal to 99. Now, how is it going to help me? So from day one, I need you to think formulas. With all of your arithmetic and geometric sequences coming, you're going to work formulas. Get the correct formula, have the formula that helps you. So which formula are you going to work with? You only have one at the moment. Namely the Tn formula. Now guys, I want you to catch this. Focus, no, do nothing else, focus, focus. I'm teaching you a shortcut here. Because you are going to say Tn is A plus n minus 1d all the time. So if we say T4, we're going to go A plus. Are you agreed? But now the shortcut is, don't do that. Just immediately say T4 is A plus 4 minus 1. What did I do? Exactly what I'm used to doing, but I'm just shortcutting it. It's the same thing. Instead of saying 4 minus 1, I'm just writing 3d. So let me see if you're catching this. So what would term 10 be? A plus?
Then term 11.
Shortcut. What would term 23 be? You're catching on this? Can't differ, it's a formula. It's just a shortcut to quickly get there. Why will it always be that way? Because the formula says, if that n is 4, that must be 3. That's what it says. So let's help ourselves here and write A plus term 4, 3. Are you using the formula? Absolutely, but you're not writing the whole thing, you're just immediately going shortcut. Is equal to 36. And for this information, we're going to write 10d. Are you catching on this?
Yes.
Okay. So now, what's left of my sum? What's going on there?
Simultaneous equation.
Aha, simultaneous equation, which you know of by heart. Now, you've learnt about substitution all the time, so we can go substitution again. Substituting the A in. Why would I go for A? Because it's the one that's alone. Can I make both of the A's the subject and then put those answers equal to each other again with the alternative ways? So now I'm going to say this is number 1, this is number 2, so that the marker knows what I'm doing. I'm going to put 1 into 2, so that my A is substituted with 36 minus 3d, and plus 10d equals 99, and this is easy peasy linear equations. Linear equations in linear or arithmetic patterns. So to find the answer, I think it's 63, and D would be? Everybody happy on that? Does D have to be a whole number and a positive number? By accident it is, but it doesn't have to be. D was just in the previous sum, -3/4. So there's no problem with that. N has to be positive and has to be a whole number. So I'm still searching for A, but my question was here, find the first term and the common difference. The question is, find the first term and the common difference. Well, I did it backwards. I first found the common difference, but how am I going to find the first term? What is the first term?
It's A.
A. So basically they're saying find A and D. But they're saying find the first term
And the
A,
common difference.
and the common difference D. So listen to the question. So to find A, I'm going back to any which one of them, and I'm going to have A is 36 minus 3 times 9, which gives me 9 again, by accident. By accident. The question was just find the first term and the common difference, and I'm done. Please make sure that you highlight. Write the question, see the question, find the first term, common difference. First term, common difference, and I highlight my answers and I know I'm done. Because can I go on with this? Can you find me the sequence here? I'm done. But can you find me the sequence?
Yes.
Where would I start?
With the A.
With the A that was 9. And how do I get to the next term? by adding 9, because that's the common difference. You're going to get 18, 27, 36. Now I'm not going to go to the 11th one, at least the 4th one correlated with my information. But if I do carry on until the 11th one, it should be 99. And can I carry on then again and find the general term, and find the 100th term, and find which term is equal to whatever. So we can carry on and on and on and on. Are you with me, everybody?
Yes, ma'am.
Okay, we don't have much more time. I'd like to look at one other fact. The fact that I'm saying sequences and series might bother you a little bit, not major. A sequence is something that has semicolons in between. You're just putting them together. But when we get to the series, we're going to get the sum of those numbers. Now, if there's pluses and minuses in between, we're calling it a series. That's it. And guys, if you never know that, and you never want to know that, it's fine. It's just a technical thing. If there's semicolons in between, we call it a series. If there's pluses and minuses, it could have all been minuses, they could have been plus, minus. Once we get to the geometric ones, you'll see them. Then we call them a series. No problem. Okay, homework.